It's a review time. Yeah, not particularly excited, right? Because exam is next thing. So, chapter 3, basics of derivatives. So we have all the rules that the derivative of what? X squared is 2x. Derivative of e to the x is e to the x. Derivative of sine x is cosine x. So all of that stuff is going to be on the menu. So that will be basic rules. Rules of derivatives. So we have basic, we have the product, we have the quotient, we have chain, implicit, and that's actually it. So those are the rules. Then we are going to have the limit definition of the derivative. We are talking about good old f prime of x is equal to limit h goes to 0 of f of x plus h. This is 3.1 minus f of x divided by h. So that limit is going to be there in one problem, no more than one problem. So review taking limits in terms of do you need to rationalize or you need to add common denominator or do the whatever magic needs to happen to solve that. I'm going to write this in blood. Find the tangent line and then 3 dots there, because you know that f prime computed at A is going to be that slope m. And to find this derivative, you might have to use the chain rule, you might have to use the product rule with chain rule, you might have to use implicit differentiation. It doesn't matter which derivative rule you are using. Well, it matters regarding the problem, but something will be there to find the derivative of the tangent line. And we have word problems, which is known as related rates. And that's it, unless you want to put in some of the chapter 4. Min, max, critical points, numbers, inflection, first, second derivative test. Anyone? I just need one yes. I think I thought I heard yes, so which one do I? Nothing? Chapter 3 is enough.
I didn't like the word problems in my math class.
The exam will have the standard thing of 10 questions, possible review, the possible replacement question. The quizzes start when? Tomorrow morning, 6 a.m. So set up your alarm clocks for 5:30. And or actually go to bed at 10 and then you will just get up like me at 4. It's okay. And then yes. The answer to that question is yes. The answer to that question is yes. You learned quickly what is the right question to ask because you pay attention. Yeah, he asked if I can extend, and the answer to that is yes, but I don't have to act upon it. I can. Will I is a completely different question, but I will still say yes. I'm the best person you know in the entire galaxy. Yeah, merciful, yes. Merciful.
That's what Trump said.
What happened?
That's what Trump said.
Oh, I'll be a little bit less merciful then in the future.
Do I have a cheat sheet for the inverse trigonometry?
If any of the inverse trig problems appear on the exam, I will include the formula right there. So no cheat sheets for the exam of any kind, no graphing calculators of any kind. You can bring in the scientific calculator if you need the calculator, maybe for the word problem when we plug values in, but this is the exam where you really, your calculator is probably much completely useless. Yes?
What about, it was 3.5 of trig derivatives? That was like...
That's basic. Derivative of sine is cosine. That's a basic derivative, yes.
I can memorize it.
Damn.
Everything under, so the only thing that you don't have to worry about are inverse trig ones. Well, you should know the inverse tangent one, but then,
But you'll get
right.
them though.
Yes.
Okay.
So that's the only ones, inverse trig ones, and I strongly encourage, if you guys are going to calculus 2 and later differential equations, just get that inverse tangent down, because it is all over the place. But the other ones, there are integration techniques that you can use to bypass that.
We have to know logarithmic and exponential.
That's basic.
That's basic. Okay.
So over here where you see this basic,
Yeah.
that's where power rule is, derivative constant is 0, derivative of ln x is 1 over x, integral of, derivative of e to the x is e to the x, derivative of cosine is negative sine.
And then the basic is the identities, and those other four are just like ways to squash them down.
Yes.
Okay. Cool.
Of course, it's cool, it's calculus. Any other questions before we do some word problems? We will do some word problems. I could. Let's talk about chain rule. Chain rule is probably the most important of all rules you ever see, and definitely the most frequent one. So what is what is the chain rule, when it kicks in, and so on. So if you want to take the derivative of x cubed, you will just go and say 3x squared. Now what happens if you want to take the derivative of x squared minus 5 cubed? Well, this is where the chain rule kicks in. Chain rule kicks in here because the value under cube is another function. You can literally think of this as f of x, everything cubed. So you have the outer function, which would be a cubed, x cubed, and the inner function, which is x squared minus 5. So the derivative of the outer function would be 3x squared, but then instead of that x, we have to write x squared minus 5, and then times it with the chain, which is the derivative of the inside, which is 2x plus 0, so just 2x, for the total of 6x, x squared minus 5 squared. So that is the chain rule. Another example of chain rule would be, let's say you have a trig function, like derivative of sine x, which is cosine x. This belongs in basic integrals, derivatives, sorry. Now, if I have the derivative of sine of x squared minus 5, then there will be cosine of x squared minus 5 times the derivative of the inside, which is 2x, as a chain. for the total of 2x cosine of x squared minus 5. So all of these are examples how you have the basic function and then the chain rule where the x from the basic function is replaced by a completely different function, and then you keep going doing that. Happy with the chain rule? Now, chain rule can be embedded in a product rule, in a quotient rule, and chain rule is implicit differentiation. All right? Any other questions for the review? Yes?
When you're looking at any chain rule problem, if you think about the outer, can you always say it's the last operator?
What do you mean?
If you're like doing the problem, it'd be the last thing that you would do.
You mean this one?
No,
2x?
the original function, like if you look at x squared minus 5 to the third power,
Okay.
you know that the last thing you would do is like the outer function is the x to the third. It's the last thing you would do
Oh,
as an operator. If you were like put it in a calculator, that was like a dumb calculator, it'd be the last thing. So in every single chain rule, you can see that, right?
yeah, but you can also have the triple stack.
Yeah.
So let's see one of the let's do one more example. So how about you try this one on your own, and then I will do it afterwards. So let's go with 5 sine cubed of 1 over x. Oh, let's not forget logarithmic differentiation. Remember the one that it's nice? Logarithmic differentiation?
Erasing everything. The whole page gone. Like, it's the one thing that you can't read the page. Yeah. I mean, everything. You lose, like, what, a couple thousand? I'm just wondering what that lose that. You know, just like, pull that through there. No.
This is a very evil problem. I was thinking to put this on the test, but apparently now it's not on the test because it's here.
Yeah. So what do I do with the cube? This is.
Well, you know it's a triple chain rule, yeah.
What?
Triple chain rule. You have to figure out what is the most outer function, and then which one is on the inside, and which one is on the inside of what.
X cubed sine of x is the bottom.
Yes, x cubed is all the way at the outside. And then you have sine on the next layer in, and then you have 1 over x on the bottom layer. Think of the onion, right? You have layers. You think you have the onion now?
Calculus is like onions. They both have layers and they both make people cry.
Ooh.
You know I stole that from Shrek, right?
No, but definitely done. Shrek? I saw all the Shrek.
Yeah, it's ogres are like onions. We both have layers and we both make people cry.
Okay, I will have to read.
It's calculus.
I will have to revisit Shrek.
It's
I have a friend who looks at
it's a great series. Perhaps one of the most greatest film series. Like step aside Star Wars, you know. I don't know what you're talking about, sir. Shrek. Got everything there. Conversation like at least once a week. So, how do you decide which one is the outside function? That's not gonna
You, okay, so the question is, how do I decide what is the inner, middle, outer function, and so on? If it gets complicated, like in this case, where you actually have 3 functions on top of each other, you can easily determine that by imagining that this x is a value, and how would you compute that, right? So if x is, let's say, 2, the first thing that you would do is divide 1 by 2. And then you would take sine of that, and then at the end you would cube it. So now reverse those, right? So the cube is the last thing you would do, that's the first function on the outer layer, and then sine is the second thing, and then...
So that's what I meant by the last operator, is always outer function.
The one that computes, yes.
Okay.
Yeah. Every time That's the hour.
This one I never did sine of x. I never understood that.
And then the last one is 1 over. And how is that deal? Because this is 2. That's 2. So therefore, then sine of x.
So where do you want to go? Oh, no.
It's fine.
Alright. I know what the layers are. This is what I have.
There's no formula. There's no formula. So
saw a banana and I saw some kind of like furry. I don't think I would be able to do it. Yes. On May 28th, we lost the great one.
I want to be a basement fund and I have to work on it, which is like 14 hours. And so sometimes when I focus the activity, I have the meeting.
Yes. Something within the realm of possibility. Definitely. So far, yeah, I don't know. You know, one of those right because I haven't done it yet. Always a good thing here. Within the realm, definitely. You get to see something. I like to see it because it's definitely fun. Sure.
It's like exit.
You like that?
All right, let's talk about this problem. So, we have triple layer here. We have x cubed all the way on the outside. We have sine x in the middle, and then 1 over x on the most inner function. Again, how did I determine this? I determined this by saying that this x over here might be number 2. And then the first thing I would compute is this, get it as 0.5, let's say. And then that 0.5 would be plugged in here. So that's the second layer. And then whatever I get for the entire sine x would be plugged in for this x and then cubed at the end. So I just reverse those steps and I write the assignments for functions. So now that I see that, I go and I say, all right, so copy constant, which is 5. Derivative of x cubed is 3x squared. So I have to have sine 1 over x still in there. Then the derivative of the inside, which would be cosine, derivative of sine is cosine 1 over x. And then finally, the derivative of 1 over x is very good. So now, the grand total over here is negative 15 over x squared. Sine squared 1 over x times cosine 1 over x. Happy? Now, guys, this could have been a step in a problem which says find the tangent line for this function at x equals to 1, right? Or whatever, 2 over pi. Right, and then you go and you figure out the tangent line afterwards, because now you have the derivative and you can find the slope and then the rest. It'll look like a quadratic stuff, and then a cubic.
Could you do like a chain rule and then a chain rule?
So I'm getting, guys, are you listening? Because he's giving me ideas for the test. What is it?
Well, what I did was I did a chain rule with the 5x cubed and the sine x.
Okay.
And then did a chain rule with the 5 sine cubed x and 1 over x. I just did like an extra step.
Yeah, don't do.
Just make it like this.
Yeah.
What? I did an extra step.
Any word problems you're interested in? Anyone?
I don't want it, but I feel like I'm kind of active. One where you have to find the tangent line.
Tangent line of something? I can. Tangent line of what? Trigonometric function? Sounds good? All right. Find the tangent line for function y equals 3 cosine of x over 2 at x equals pi over 6. No, pi over 3. Pi over 3. There you go. So try this for about 17 seconds, and then we'll do it together.
Or we have to like ever know the unit circle.
Well, it would be very beneficial. I mean, you're gonna have your calculator, so.
That's what I'm saying.
But
Are you gonna make it?
I mean, memorize it? No, I won't make you anything. But just imagine how awesome it is when you go out and you bring that up, and no one else knows, but you're the boss.
Slightly to kind of like try to think through the special triangle.
Remember years ago in 11th grade?
Nah. You bring it up when someone says, what do you know? I know that tangent of pi over 4 is 1. What do you know? It's like right back in a court, right?
Get shoved into a locker and it's just like high school again.
All right, let's take a look at this and then do some word problems for the 50th time. I'm trying to get there. So first derivative is going to be negative 3/2 sine of x over 2. Because we have the chain rule, a half is going to be kicked outside, and derivative of cosine is negative sine. So all of that in effect. And then we will plug in the value. So slope m is when you take the derivative and you plug in pi over 3. So when you replace a number, x, with the actual value, that's when we're getting the slope. So that's 3 times the cosine of, in this case, pi over 6, which is 3 root 3 over 2. Cosine of pi over 6 is root 3 over 2. And now we have the slope. Well, we also need the y value, which is f, original function, computed at pi over 3, which is 3 cosine. Wait, why did I do? All right, so hold on. So yeah, go on. Then recompute percentages. Ugh. So sine of pi over 6 is 1/2, so we are talking about negative 3/4 on the slope. And we're talking y is 3 root 3 over 2. So y equals mx plus b. We have y as 3 root 3 over 2 is equal to slope, which is negative 3/4 times pi over 3, I guess, plus b, which works out to b. B equals 3 root 3 over 2 plus pi over 4. So b is everything over 4. We have 6 root 3 plus pi. So what's the tangent line? It's y equals negative 3/4 x plus 6 root 3 plus pi over 4. Good? Close enough. What do you mean close enough? Any two numbers are infinitely far away. If you don't have exactly this, it's infinitely far away. There's no close.
could just like simplify it differently.
Now you can simplify it into this.
Yeah.
So I should actually add here logarithmic differentiation just in case, so we don't have any issues with the review. Logarithmic differentiation is that cool one when you look at the problem and you know immediately what the derivative is. That completely takes care of all these things. All right, and next one is, I guess, word problem. I don't know. What do you want to do? We have only 2 minutes left, and then another 20 after that. I'm sorry? Yeah, sure. Why not? That's what your heart desires. You don't mind it?
I think it's important to go over.
Sure. I'm still waiting for word problems, by the way. That's the only thing that's going to make me happy today is word problems. Like, not even close. We did all of these other things. That's okay. I'll put 4 on the test. Stream has no clue what just happened. It's okay, Stream, I won't. So function f of x is given by x plus 5 to the 10th times the square root of x squared minus x plus 8 divided by sine to the 5th of x. Awesome. So you have a choice to either use logarithmic differentiation and be done in a few seconds, or do your quotient rules with product rule and the chain, which you might have to turn the notebook sideways and then do the landscape thing.
original function from the list goes down, and then it's really the top. Oh my god.
Let's write out the solution for this. So the way we do this is we write ln of y is equal to ln of, and in the argument we have this x plus 5 raised to the 10 square root x squared minus x plus 8 divided by sine to the 5th, like this. And then we expand everything. This is if you are doing all of it. It's going to be 10 ln of x plus 5. So exponent goes in front of the log. The top was multiplied, so plus 1/2 ln of x squared minus x plus 8. And then finally minus a 5 ln sine x. X. So now ln y is equal to, sorry, we are taking the derivative now. So we have 1 over y dy dx is equal to 10 times 1 over x plus 5 plus 1/2. You copy the function as is in the denominator and then put its derivative in the numerator, because that's what the derivative, right? It's f prime over f for logs. And now minus 5, you put sine x and its derivative cosine x goes in the numerator. We move y to the other side to get dy dx alone. So function itself times, so that's going to be x plus 5 to the 10th times the square root of x squared minus x plus 8 divided by sine to the 5th x, and then times 10 over x plus 5 plus 2x minus 1 divided by 2 times x squared minus x plus 8 minus 5 cotangent x. Done. Logarithmic differentiation. Yes.
So I'm there just, oh wait. Okay, yeah, okay.
Now, it's very useful for problems like this. So try if the function is equal to, let's say, sine raised to the e to the x squared plus 1, right, of x. Maybe I should put it, let me write it differently. Sine x raised to the e to the x squared plus 1. So you really, right, so try that one. Try maybe x squared plus 7 raised to the cosine 5x. Like, these are good examples for it, for this type of differentiation. Yes? You totally forgot what?
What I was going to say.
It will come back with time. Okay. "30 seconds left and then another 10 minutes after that. Any other questions?
Maybe a word problem.
Yeah, right?
I've been asking for an hour and a half, and I have that on the file here. So, which problem? Well, I don't know. I haven't done that yet. So, related rates with acceleration. You mean you want me to do it very fast? Some of these problems I can just look at it and be done. Where's the acceleration? I don't think there are any acceleration problems here. There's on velocity, sure. But in terms of the exam, I would. Let me just check. So, first 18 problems in a textbook. I would say you can definitely expect something from first 18 problems in a textbook. Is there first 18 problems? Oh no, these are review questions. So 5 through 18 problems in a book, 5 through 18. If you can do every single one of those, you should be good for later rates.
Which textbook?
Our textbook.
The one that the school says we have to redo.
Yes, but if you do not own the textbook, there is one in library on reserve, there is one in tutoring center, and also my MATLAB has the textbook with homework problems and everything else. So you do have access to the textbook, or you can just take a picture from your comrade.
Okay, because that's the textbook I have. So.
Our regular textbook, the textbook we use in class. All right, so which problem? Anyone looking at those problems right now?
Well, just do 12. It's like a nice number.
12? All right.
I don't have everything.
Shrinking cube. Well, we can think about the ice cube melting, right? Problem number 12, related rates. 3.11, problem number 12. It says shrinking cube. The volume of the cube decreases at the rate of 0.5 feet cubed per minute. Now, we can actually do the two things. Because it's the volume that is changing, we have dV dt, and we can also put this to be negative because it's shrinking, it's diminishing. What is the rate of change of the side? So what is the rate of change? They immediately want to know, let's label a side as A. So they want to know that when the sides are 12 feet long. That's a big ice cube. So this is a cube. Sides A. What happened? And now we have that the volume is A cubed. We will differentiate that to get dV dt is equal to 3A squared dA dt. So we are differentiating our volume equation to create what we call related rates equation. And now all we need to do is to plug everything in. We have Negative 0.5 is equal to 3 times a is given as 12, which will be squared, and then dA dt is what we are looking for. So we have 144 times 3 is 300, 420, 434. No, 2. 442?
Yeah. 430.
That's what I had. dA over dt. So dA dt, which is the concept we are looking for, is negative 0.5 divided by 432, which is clearly negative 1 over 864 feet per minute. So we see that the sides are decreasing by this value.
So we only need to go for twice. It's right. We should go like acceleration versus position. But I don't think you can do that. Like, give us one more. Not yet.
Ever.
Thank you.
That's the word problem.
Wait, that's it?
Why, disappointed? It's application. That's how it goes. I'll do another one?
Yeah.
Yes, that's the spirit. Which one?
Playing with the crossword.
We have only 1 minute left and then another 2 after that. For the official time, but we can stay longer, it's okay. What was the next one?
Playing with the false when you're
So looking for 5 to 18, including 18. And I believe I did 16 in the class. I did 15, 16, maybe even 14. Now we did 12. Anything else? I'm just gonna sit here, it's okay. Anything?
45 and 46. Oh, you said 115. Oh. Sorry. 46 looks like fun though. Yeah, it does. It's two tanks and one of them's a cone and it's emptying into
through a giant storm.
Don't worry about it. Project is coming up.
What is race car Precalculus?
No, don't worry about it.
When's the project?
It's due the day of the final exam, and it's assigned this week.
This week or next week?
This week. It's just uploaded in files.
Oh, cool.
It's just gonna magically appear there. Where the notes are in the syllabus, there's a separate folder that says project. Right there. It's just going to materialize. Any other questions? Did you ask about, is anyone vegetarian?
Oh yeah, we should probably talk about the.
I guess I'll just end the stream because it's just getting to that point where we need to end the stream. Because we are done with the review and the class is officially over. We went 15 seconds over time.